refer back to it later, you can. We shall see, right? So here we go. I have this graph, and I know it's hard to see. This is the derivative. Describe and classify the relative extrema. Okay. Well, if this is the derivative, where are my critical numbers at? At negative 1? At, what value is that? 1, 2, 3, 4? Let's just call it negative 1. Let's call it 4 and 7. Why are those critical numbers? Because the derivative is equal to 0. Okay? Where are my relative maximums at? When my derivative is negative, that means my original function's what? Decreasing. When my derivative is positive, that means my original function is increasing. This is a relative what, guys? Minimum. So I have a relative minimum at, what is it? We're going to call it x equals negative 1. I have a relative maximum where? X equals, is that 4? Is that what we said? 4? Why? Increasing 0. Oh! Increasing. That's neither. Increasing 0. Increasing. Yeah, that'd be strictly monotonic in that interval. But I do have a relative max at, what did we say that was? 7? Because it goes from increasing to decreasing. Cool? All right? All right, here we go. Continue on. Number 2. Below is a graph of the second derivative. Answer the following questions. Okay. Well, where the second derivative is 0 are possible points of inflection, right? When the second derivative is positive, Ms. Belden, that tells me concave what? When my second, I'll say it again. When my second derivative is positive, that tells me what? Concave. Up, down, up, down. You got 50-50. I love how you're looking at my face and trying to go off my face. I will make faces just to make you doubt yourself. It's concave up. When my second derivative is negative, it is concave down. So we want to basically find where my second derivative is 0 and it changes from positive to negative. So with that being said then, there's a point of inflection at B. Would everybody agree with that? There's a point of inflection at D. There's a point of inflection at F. So A, on what intervals is H concave up? We would say from B to D. So I should write that, right? From B to D. Anywhere else? I would go from F to infinity. Does it say? Yeah. Or you could say, I'm going to go F to infinity because I see an arrow. Cool? Yeah, my second derivative is positive. That's simple. Second derivative test says what? If my second derivative is positive, concave up. If my second derivative is negative, concave down. Amy?
What about when you draw when we were drawing the tangents?
Yes. Okay, there is no need to draw tangents here. This is the second derivative. We don't. Yeah, that would be talking third derivative. I know. I've not discussed any.
The first derivative then.
First derivative, we were thinking tangents, and that was. So if I went back up here to, you want to go back up here to this one real quick? Can I detour? Shh, here we go. I'm going to detour. Right up here, Amy. If I drew tangents to this was a derivative graph, right? So that means everywhere that the derivative is increasing, that's concave up, concave down, concave up, concave down, because when the derivative is increasing, it's concave up, because this is where I would draw all the tangents, and all the tangents would be positive, which makes the second derivative positive.
Oh, okay.
Cam?
So all the places where the tangent is 0 or undefined are possible points of
Possible points of inflection. So if I went back to this graph, my possible points of inflection would be here, and it actually is one. Why? Because I change from increasing to what? Decreasing. This is also, because the second derivative is undefined, yes?
Yeah.
And I go from decreasing to increasing. Okay? Increasing to decreasing. Now, what you got to be careful of is though the first derivatives were undefined. So you got to be careful. Those may be vertical asymptotes, which therefore you can't have possible points of inflection at vertical asymptotes. Okay, I don't have enough information to know that.
They would be vertical asymptotes on the original graph?
On the original graph. Okay, so I'm going to go back to here. Where is this? Where is this concave down? It'd be where the original values are, or where the second derivative is negative. So it'd be from 0 to B and from D to F. And I'm going to see how it says when is H prime concave down. We're not talking about that. I'm talking about when H. So I'm scribbling that out. So I'd say from 0 to, what did I say, B? And also from D to F. Yes? And we just said points of inflection would be B, D, and F. No. Yes.
Yes.
Yes. Thank you. I was thinking first derivative. I was going back to first derivative. Okay? And we also recognize this because that's where concavity changes. All right, number 3. Now I give you a chart. It says to draw the graph of f of x based on the following chart. Okay? Given that f is continuous, f of a equals f of e, which they both equal 0. So that's what we want to mean first. So let's graph this. So we're going to go from left to right. Okay, I don't even need a y value. I don't like my graph. What I really have is, because I'm going to treat them all as positive, I really have is this. Let's just start here at A. So I have A, B, C. What else do I have? D, and anything else? E. Okay. And I said where do I have 0 at? F of A is 0. And F of E. So we're finishing right there. Okay. Here we go. Look at your chart. From A to B, my function is decreasing and concave down. Decreasing, concave down. So that'd be like something like this, wouldn't it? Decreasing, concave down. It says at B, my derivative does not exist, and the second derivative does not exist. So I'm going to come to a sharp turn. From B to C, I'm going to, since the derivative is positive, that means I'm going to increase, but stay concave down. So that works out nice. I can come to a sharp turn, and I can do that. That's not the most, let me clean it. Let's try that again. So I think I just made it worse, but I think we get the point. Is that still concave down? Now, this time though, it says at C, my derivative is 0. But then it's going to keep doing what? Increasing. So that's what we're talking about, where I got to make this even more. Yeah, this is even more monotonic, isn't it? So I'm going to come in here. I'm going to do this. I'm going to come in here. Right here, that derivative becomes 0, and what's my concavity become now? Concave up, which is like that. Would everybody understand why this derivative right here is 0? And then from D to E, I'm going to continue to go concave down, concave up. The derivative at D does not exist, so let's make it a sharp turn. Let's go down with the concave up. Let's decrease concave up. What do you guys think? Ask me questions about it. I'm going to come here. Does everybody understand why that derivative is undefined, does not exist? And why that derivative does not exist? But why this derivative is 0. And, what is that? C, point C? Look, the second derivative is 0. Concavity changed from concave down to concave up. That's a point of inflection. Would you agree? This is a relative max or minimum, and the absolute minimum, Amy. This is a relative max, but also an absolute max. All right, next problem. On what intervals is the function g of x? Okay, it says use your calculator, so I'm going to end this recording.